Zach, you don't want it?
No, thanks.
Okay.
Did you guys eat all those? Damn. All right. Here we go. Anybody have any experience with robots? Programming them? Anything? Working on the motors? No, nothing. Okay. First thing first, robots are very, very stupid. They're not going to do anything unless you tell them to. That's right. That's the wrong one.
It's not good when you start off with a handicap.
Correct. I believe I started putting the assignments on there. The assignments for this class are mostly just going to be labs, okay? And then you're going to have all semester to do these. There's no due date on any of these things except for the end of the semester, so don't let that stuff pile up. Also, we're going to do a little bit of lecture like this every Monday and Wednesday, and then Friday will be lab day, so I won't take attendance on Fridays, but I'll take attendance on the other days. So on Canvas, assignments, labs, Robot Lab 1. Using the FANUC LR-Mate 200 IC, jog the robot in all world and joint directions and rotations. Worth 10 points. So there are 3 different robots you can use. 2 of them are identical, or there's one out in the lab that's identical to this one, the 200 IC. The other one is that 480 volt one that we just hooked up the other day. That one has a little bit older teach pendant, but the functionality of it is all the same. You might see some things moved around on the screen that are a little different than this one. But all 3 robots you can use for this lab because all you're doing is jogging the robot. All jogging means is that you're manually moving it one direction or another, or rotating the joint. So there's a couple different ways you can do this. What's the lab say? All world and joint directions and rotations. Okay. So what joint means is that each one of the joints on the robot should be a freaking cinematographer at the same time. Jot this wrong. Anybody take a look at that robot and guess how many joints it has that could be rotated? There are 6 on this one. The one in the lab that's identical to this one also has 6. The 480 volt one only has 5. It does not have this last one out here that rotates, I believe, in this direction, this last one here. So it will do 1 through 5, but you can still use that to do this lab. When you're jogging a robot, you're going to jog it to create programs too, but you have to know what coordinate system you're in, okay? Right now, we're in joint mode. I don't know if you can read that up at the top of this is called a teach pendant. And all this is a way to communicate with the controller and tell it what you want the robot to do. So it's in joint mode, that's up here in black, and then to change it, this button down here is the coordinates button. And if I hit that button alone, it will change it from joint to jog frame to world and tool, user, which we'll get in all these other different frames later on, and then back to joint. A frame is just a point of reference or a reference system for the coordinates that this thing is going to use. So anytime we create a program, we're going to tell it exactly where we want the robot to end up, and we're going to tell it how we want it to approach that point. And then it's just going to be a sequence of points in your program. But every single one of those points that you put into your program has coordinates, just like these X, Y, Z, W, P, and R, and those mean yaw, pitch, and roll. I'll get to that in a second. But if I go to any program, real quick, I'll just show you what that looks like. Go to select, and this one says main program. I'll just find a different one. So here's a program, and all it is a list of points. You're telling it, go to user frame number 8, label 1, we'll get into jump label later, but down here, this point number 3, this is telling the robot in the using joint mode, go to point number 1 at this speed and at this rate. But if I actually go over to that point and I hit enter, whoops, I'm supposed to go to the number. There we go, enter. Nope. 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 Position F5. There it is. Position 1, user frame 8, blah, 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 and it's got all these different coordinates. So those coordinates are relative to where you're telling it to be in the frame that you're in. When you're in world mode, the 0, 0, 0 point is at the base of the robot. So right in the middle, I can't point exactly to it, but right in the middle of the rotation of this base joint. So this is joint number 1, this is joint number 2, joint number 3, joint number 4, joint number 5, and this is 1, 2, 3, 4, 5. Oh, this one, 6. 1, 2, 3, 4, 5, 6. Like what I do with my hands there. That's nice. 6, 5, 4. Okay. All right. So in joint mode, all you're going to do is make sure that you are in the joint frame. And when I do that, you're always going to, when you pick up the teach pendant, it's going to be faulted because this thing will not move the robot unless you have what's called the dead man switch pulled down. The dead man switch is on the back. There's actually 2 of them. I think for the 480 volt robot, there might only be 1. But these yellow things are dead man switches. If you want to reset that fault, you have to pull this in. So you cannot move the robot without this thing being pulled in. There's two different depressions on this. There's halfway in and then all the way pulled in. And that's a little harder to do, but you're only ever going to, for this class, use that halfway pulled in thing. So if I halfway pull that in and then hit the reset button, which is right here, you'll see that fault go away. And if you saw that the red spot there says fault, probably can't read it, but I'll let go of that dead man switch. You see how it's faulted? And it says servo 003 dead man switch release. That's the fault that it's in right now. So pull the dead man switch in, hit reset, and that fault goes away. Now with it in joint mode, every single one of these XYZ points, they're labeled. Zoom a little closer. See that top negative X and plus X is joint 1, J1, J2, J3. So those are all 6 different joints. The top one would be, it starts at the bottom or the base of the robot and then works its way up. So for joint number 1, X, you're going to see that it rotates left and right at the base of that robot. Ready? Oh, in order to move it, you have to hit the shift button too. So to move it, there's 2 different things you have to do. Pull the dead man switch in halfway and then hit shift while you're hitting these buttons. So here's negative X direction. Bump the speed up a little bit. So that's negative X, and this is plus X. And then joint number 2. Joint number 3. Joint number 4. Joint number 5. Joint number 6. These are all the different joint rotations you can do. So that's half of lab 1, what I just showed you. Okay. Did you all see how slow it moved before I bumped the speed up? It will move right now. It's at 100% speed. It's in the top right corner of the teach pendant. What I just showed you was 100%, but it will go all the way down to really fine and very fine, very slow movements. And that's for, you want a really precise point at the end of your tool. But you guys are of a generation that's really good at things like video games, but don't bump the speed up to 100% unless you're absolutely certain you know what it's going to do, okay? Because that thing is really dumb and it will hurt somebody or break something if you're not careful. For instance, some of your labs are going to be, you're going to draw your initials on one of the laminated papers, right, with the marker like it's attached now. And so many times I get people that just want to fly through this and they go into world mode and they go 100% minus Z-axis and just fly down there and then wham, they go driving that marker like through the table or bust the thing. And it does have safeties in there to where if it detects a collision, it will shut itself off, but it will break stuff and it will hurt people. So please, please be careful. Take it slow. If you get better and better at it, I don't care if you bump the speed up a little bit, but just don't be stupid. These are not cheap, and there's no reason for anybody to get hurt. Okay, off my safety spiel. So that was joint. All right, the other one in the lab talked about world. I've already put it in world position, but to understand world, we need to look at coordinate systems. Do y'all remember Cartesian coordinates from like junior high, high school math? Yeah, so it's a 3-axis coordinate system. You see my awesome, whoop, 8-pin. Oh, paint, cool, there we go. Okay. So X, Y, Z, how you would learn it in your math class is this is plus X, this is plus Y, like you're graphing something. And then Z, now we're going three-dimensionally, and we have to imagine that this is going into the screen, right? So this would be plus Z. So everything on here would have a coordinate. So if I wanted to tell the robot to go to this spot here, you can't really tell if it's on the Z axis or if it's closer to the X axis. So there's always these triangulations is what it's called. So this is, if I go straight down the Y to here, and maybe it's this far away from X. So it'd be like 2, 5, and then how far away from Y is going to be on the Z. So make this 8. Can you kind of visualize in your head where this point would be? Remember, we're right here, and we're trying to figure out where it is three-dimensionally. Can you visualize in your head that this plus Z is actually coming through the screen towards you? And then minus Z back here would be going into the screen away from you. So these coordinates then would be, it's always X, Y, Z. So this would be on the X axis, where is it?
So like the height above the table or close to the table it is?
Mm-hmm. And the default in world mode, 0, 0, 0 is in the base of the bottom joint, right? Like I showed you before. So I'll show you what those coordinates mean in a minute. But for this example, where would X, Y, Z be? What would the coordinates be at this point? What would X be? -2. It's actually, if you draw a straight line over here, this would be -2. So -2, Y. So Y is up and down vertical, so that would be 5. Z would be 8. So these are the coordinates of that point. Now for most of the labs that you're going to do, you're not even going to need to know what the coordinates are. You're going to need to know what frame you're in, like jog or world or tool or user. But you won't need to know these coordinates. Where this becomes really handy is if I asked you to weld a 10-inch bead on something, you could put the tool, so the welding end, on the piece and record that point, and then say, okay, I want you to go in the Y direction, minus 10 inches or plus 10 inches, right? Does that make sense? So it is very useful in the field to know how to manipulate these coordinates and know what they mean, okay? I think you'll have probably one lab where you're supposed to draw a 10.2 inch line by manually entering the coordinates. Does that make sense? The other reason you need to know this is that there's a standard in World, which right now somebody has gone and screwed the reference position up, because this won't show, when I show you on the teach pendant and show you on the robot, it's not going to end up how it should until I re-record that reference position. But let me try to draw this first and then I'll show you. So this would be looking down at the table. And then here is the base of the robot. And then I always go off of where the power and communication cords actually plug into the unit, and it's always on the back right here. And you can look at these later, okay? But where those plug into, the direction that those plug into the machine, that's always in the plus X direction. So this is always plus X. This is always plus Z or plus Y. And Z is up and down. So Z would actually go straight down into the ground. So this would be minus Z. And positive Z would go straight up towards the ceiling, if you can visualize that. So if you were going to take that marker and you're in world view, world frame, and you wanted to drop it down straight down into the table where you were going to make your first point, what direction would you jog the robot in? Minus Z, straight down to the table. So the difference between joint and world is that if you did minus Z on joint, you're gonna rotate the third joint, right? You're not moving it according to these world coordinates. Does that make sense? Most of your programming, you're going to use world to jog in. Anybody know why? No. Why would it be better to jog the robot around in the world frame rather than the joint?
Less complicated?
It is less complicated as long as you understand this. If you don't understand that, it won't be less complicated, but it's a lot quicker. Can you tell me why?
Instead of going like around in a different way, you can just go straight to the coordinate.
Yeah. There's two reasons. So let's say I wanted to jog the robot to put the tip of that marker on the end of this bolt. So let me show you what that would look like in joint, and then I'll do it in world. So joint first. Remember, when I do joint mode, it's going to move one joint at a time, right? And I want to put that marker down perpendicular to the table. So let me go to hit coordinates, and I'll go to joint, and then I'll raise this thing up. So I need to take probably joint number 2 back a little bit. And then I need to rotate number 7 down a little bit to make it perpendicular. And then instead of dropping it down straight, like we talked about with just Z, I can't even tell if I'm right over the top of that bolt, but at this point, you could just drop it down straight with Z. You're already probably starting to see why this takes longer than using world. But in order to get that to drop straight down to Z, I have to move like 3 or 4 joints. Go like that, and then bring this down. Try that. Oh, that's pretty close, right? And that actually went really well and really smoothly, but that's using joint, and I got lucky. But you saw how I had to manipulate 2 or 3 different joints just to get it to come straight down perpendicular to the bolt, right? So let me get out of that. All right, so in world, from this position, where would plus X be? Where would that move that? Straight. Remember how I told you the plugs in the machine? That's going to be plus X, and it's off in here now. I got to fix that, but I would need to go plus X a little bit, plus Y a little bit, and then Z it straight down, and you're there. That's 3 manipulations to get it to where you want to go, instead of moving this joint and then that joint. And you can see how using world frame is going to be a lot more consistent for you, right? The other thing about world is that when I'm moving Z straight up and down, it always leaves the tool perpendicular to where you have it or where you left it. So if I wanted the tool straight out like this, perpendicular, it's going to leave that there. Now I'm in world, let's see, put it in world, and I go plus Z. You see how it keeps that pen parallel to the ground? And the same thing if I have that, whoa. Whoa, 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 whoa. He's like dancing. Oh. Put that perpendicular now. And you'll see when I go in these directions, I'm going to go plus X first, and it will keep that marker perpendicular to the ground. And you can see it's moving multiple joints at the same time to push that thing straight out in the X direction. Does that make sense? All right, and then this would be plus Y. It's screwed up in this thing because somebody moved the reference point, but this would be plus Y. Bump the speed up. Whoa. And another nice thing is it keeps it kind of parallel with that edge of the table. You know what I mean? So once you get it lined up that way, then you move straight in that axis direction. It'll put you right over the head of the bolt. Let's see what it's doing. All right, so I got it somewhat lined up, and I'll show you. I'm at 10%, and it might be okay to bump it up to like, I don't know, 30%, 35 to bring it down towards the head of the bolt. Get it an inch or two away, and then bump the speed down to about 5% or even less to get it closer. So this would be my Z. I can't really gauge the depth, but that's pretty darn good. So I'm right over the head of the bolt, and then I'll bump the speed down even more to like 2%, right? To go to my Z until the felt is just kind of barely touching the head of the bolt, right? So there it is. Another thing with, I only have so many dry erase markers, so please take your time when you're doing those labs, because cramming those things up into the marker, they get destroyed pretty quickly. And you have to be kind of careful too. Like you want enough pressure on the point where you're doing those ones to where it'll draw the line you want it to, but not so much pressure that it'll smash the felt into the marker and then stop recording the points later on, if that makes sense. So any questions on joint and world frames and how to get to them, how to bump the speed up and down?
Which button is the speed?
Speed is down towards the bottom. I don't know if you can read it, but you'll be able to see on the video. This is percentage. And if I hit, this is a little trick like that you can use throughout this class when you're writing your programs or jogging the robot. But anytime you hold the shift button down and then make an adjustment to the speed or anything, it will do it faster. So if I just hit plus percentage, you'll see it goes up 3, 4, 5, 10, 15. But if I hit shift and go up, it'll go straight to 50. And then straight to 100. So no shift, just increments by 5. Shift, shortcut to 50, and then 5, and then fine. So it's kind of a shortcut. And you'll get used to doing that kind of stuff as you get better and better at jogging the robot and making your programs. So that's the speed. This is the coordinate button to change from world to joint. Should be about all you need. I don't need to see you actually jog the robot in all rotations manually, but we're an honor system. I want you to do it. Tell me when you're done. When you're done, I'll give you the points. Make sense? And this is due when?
Whenever we're done with it.
May something, end of the semester. So don't fret just because you don't get a robot right away. Cool? Any questions? I guess let me show you real quick how to power these things up and down. Jog that away from that bolt. Another thing, when you're done with the markers, if you're on a marker lab, please put the cap back on. Remember I told you too that like I was recording this for you to use, and like I know you guys are all doing this because I know you're taking notes, right? Cool. I don't want you to go to a lab and say, hey, how do I jog it in the X direction? How do I jog it? How do I change the thing from world? I'm not going to tell you. You got that, and you got an enormous manual. Cool. I'm an a-hole. Anyway, power this thing up and down. The tool itself uses pneumatics wherever the operation. You've got two sets of little grabbers like this. On each one of them, you should have a little regulator, air regulator. So if you find some stuff and plug it in, now that thing's going to be able to open and close. So that's just for the tool. You don't need the tool for the first lab, but I'm just showing you. Power them up. There's a breaker on the controller. So this is the controller. It has all the servo amps and stuff in there. Flip that thing on, and you'll hear it take off like a freaking jet engine. And then it'll go through a little boot screen on the teach pendant. The other identical robot to this one has a suction cup on the end of it. That's how it, anyway. Oh, Joe Biden there. So it's got a suction in it, and take the thing, if you hold near and dear to you, anyway. Yeah, that one is a little different. There's actually another panel mounted next to it that has some fuses and breakers, and even got a little drive in there to run the conveyor motor. That one will not power up right away unless the disconnect on the side of that is also on, and then there's a little green push button you have to turn on. Then it will power up the same way that this one does. The 480 volt one is exactly the same as this. It's just a little older. So the teach pendant looks different, but it's nothing scary. It operates the same as these ones do. Air, power up, jog. You guys good? All right. Good class. We do the 8-hour sandwich. That's kind of counting on leftovers for dinner. Man.
They were delicious. There's a bag full of things.
Bag full of what? Oh, do you guys like any chips?
Yeah, and the whole Lay's dinner.
Is it chips? Who wants chips? Anyone? Mayonnaise, mustard? Chips, mayonnaise, mustard?
Mayonnaise and mustard.
Mm.
Free condiments.
Mm-hmm.
This is the air.
I don't like
That's the regulator.
Is it just because tissue felt better chip or just like a better version of white?
Depends on that mill too.
That is true.
Besides, like, I mean,